All right, this is still part of chapter 1, and we're getting really close to the end here. We're in multi-part lesson 2 and right at E, so 2E. And our main idea and what we're going to be focusing on in our conversation throughout this video is dividing decimals by decimals. Seems intimidating at first when you first think about it, but as we get going through this, you guys are going to see as long as you understand the basic algorithm of division, just like in multiplying a decimal by a whole number, you'll be able to do multiplying decimals by decimals. So let's talk for a second and go back in our history of what we know about place value. So in place value, that's where numbers fall, and what we call them in our place value chart. We have the ones place, and from the ones, when we move to the left, then we go to the tens, and then we move to the hundreds, and so on, and so forth, going up to thousands, 10,000s, and continuing up with our place value. If we go to the right of the ones place and we start taking apart one whole, we put a decimal in, and now we have tenths. Then from tenths, we move into hundredths. And from hundredths, we have thousandths. Okay, and from thousands, we have 10,000s, 100,000s, millionths. And moving on, we call them, or I refer to them as the thuses, because it's pretty much the same place value that's to the left of the ones, which is to the right of the ones, but has a th added to it. All right, so when we talk about this, we know that we can think about money. So if we have a $1 bill and we want to exchange it for a 10, we can make it 10 times bigger because we'll multiply by 10. So 10 ones is $10. So for moving up, we times it by 10. To move up to the hundreds place, if we have a 10, we know that it takes 10 tens. Kind of probably as a kid, your favorite things to say to sound like you know higher multiplication. I know 10 times 10 is 100. Well, 10 tens is 100. So everything's moving up by 10. On the flip side, if we were starting with a $100 bill, we know we could break that up and share that and divide it by 10, and we'd end up with a 10. If we had a $10 bill and we were going to share it, we could break it up and divide it by 10 and give everybody 1. So as you move to the left, you multiply it by 10. As you move to the right, you go down by 10. That is the same pattern that continues on into our decimal place values. When we talk about decimals, a tenth, think of it as a dime. How many dimes do you need to make a dollar? Well, you need 10, so you would multiply. 10 dimes is $1. Okay, and so thinking now of a hundredth, like a penny. So how many pennies do you need to make a dime? Well, you need 10. So multiplying 10 by 100th is 1/10. And then same with a thousandth. If we had a thousandth, we could multiply it by 10 and we would get 1/10. Going down back the same way, starting at the ones. If we had $1 bill and we were going to share it with 10 people, we could divide it by 10 and end up with tenths. Moving on, we could divide a tenth up, take 1 dime, we could exchange it for 10 pennies, hundredths. And if we did have a dollar or some sort of coin to represent 1,000, it would take 1,000 of these to make a dollar. If we had 1 penny, we could break it up by 10 and have 1,000. I'm going to refer to this somewhat throughout the lesson and especially tomorrow, so that's why I wanted to spend some time looking at a place value chart. So every time you move to the left on the place value chart, you're multiplying by 10. Every time you move to the right, you're dividing by 10. In that same regard, if you are at the ones place, ones, and you wanted to have a $100 bill, what you would do is you would multiply it by 2 tens, and 2 tens is 100. So if you were skipping a place value to move up, you would multiply it by 100. Same with starting with hundredths here. If you had a penny and you wanted to get a dollar bill, exchange it for a dollar bill, you'd have to break open that piggy bank and you'd have to find 100 pennies to get $1 bill. So every time you skip a place value, you're going to times it by 100 because you're going over two groups of 10, or I should circle up here, two groups of 10. Kind of confusing, but I think as more as we refer to it and kind of play around with it and look at our place value chart in the classroom, you'll kind of understand that. So let's go to our workbook. This first part, you're going to have calculators tomorrow, and we're going to work together with the calculators and looking at patterns in division. But for the sake of this video, I want to spend some time just talking about what's happening and what the algorithm looks like when we're dividing by decimals. So this first example, or well, let's just look at the definition that the book puts in front of us. If I can pull this out. I'm going to start right here. My highlighter's not working for me. So when dividing by decimals, you need to change the divisor into a whole number. To do this, you're going to multiply both the divisor and the dividend by the same power of 10. Then divide as with whole numbers. What that means is, well, first of all, you do it so that you can divide using that algorithm without too much confusion with decimals. But also because we know if we were taking something like number 1 here, and we had $1.71, and we were dividing it by 90 cents or 9/10, 9 dimes. What we're doing is we're multiplying each number by 10 to move that place value. Because remember, when you multiply by 10, you move that place value, that decimal, to the right. So then what you have is 17 1/10 divided by 9. Now you're looking at just what we were doing before. The only thing that you did is you changed both the divisor and the dividend. You increase them by 10. So if you had 9/10, now you have 9 whole, or $9. Okay, if you have $1.71, now you have $17.10. It's not changing what your quotient is going to be because you change both your dividend and your divisor to increase by 10. Confusing concept, but like I said, when we look at that place value chart tomorrow and really kind of investigate why it's working that way, I think you'll really understand. If you're confused with that topic, what you need to remember and remind yourself as we divide by decimals is making sure that you are changing both the divisor and the dividend into a whole number. And however many places you move your divisor, that's how many decimal places to the right that you need to move your dividend. Then from there, you'll go back to what we talked about the other day with division. The decimal in the dividend just goes to the quotient. And now you're going to multiply like you normally would. If I have 1/10 and I have 9 people, can't share it, so now trade it in for 10. And with the 7, have 17 ones. 17 divided by 9 is 1, because 2 would be 18. So 1 times 9 is 9. We're going to subtract. We have a remainder of 8. We don't focus on the decimal. The only thing we worry about is the decimal going up. And now we have 91 hundredths. So if we have 91 hundredths or excuse me, 81 hundredths divided by between 9 people, we're going to give everybody 9/10. I should have said 9/10, or 81 tenths, excuse me. 9/10 times 9, 81, subtract, and we have a remainder of 0. So that's kind of what they did right over here. We increased both of them. We multiplied them by 10. Moved our decimal up, and then we went back to our regular algorithm for division. Let's do a couple more here together. All right, I'm going to go right down here to A. I have 54 4/10, and I'm going to divide that by 1 7/10. All right. We want to make both of them whole numbers so that we can increase it, or so that we can divide it. So we're going to move this decimal over one place. If we do that, we need to move this decimal over one place. Okay, so sometimes it's nice to do it this way, figuring out moving your decimals, and then write it out again. Okay. You can put your decimal up, but you know, even if it's at the end there, sometimes you don't worry about it too, but for now, while we're getting used to this. So when we're dividing by a double digit, and I know some of you had questions about this today, sometimes you have to do work off to the side to help you realize and figure out how many times or how many of those numbers that you can fit into the opposite number. What I mean is when you have 17 people, I'm going to look at 500s. I know that I can't break up 500s with 17 people. So now I'm going to look at 54 tens. So I have 54 tens and I have 17 people. This is where estimation can kind of come into play. If I would round 17 to 20, so 17 to 20, I'm going to think of how many 20s can you share, or how many, with 54, how many can you share with 20 people? And we can put, you know, 2 20s would be 40, 3 20s would be 60. Let's try 3. So you're going to try 3. Sometimes kids off to the side will do 17 times 3, or what they'll do is they'll take 3 times 7 is 21, put the 1 down, carry the 2 right here. 3 times 1 is 3 plus 2 more is 5, and that's just enough. But that estimation kind of gets you around. You could start with 2. Let me show you how that works. You could start with 2 and say, well, I know that two 20s are in 54, and 3 is 60th, so that's too high. So let me try 2. 2 times 7 is 14. Carry the 1. 2 times 1 is 2, plus another 1 is 3. So 34, and then I could subtract. Well, right now I have another 20, and if your number when you subtract is larger than your divisor, then that means you can divide up again. Okay, it's kind of like splitting with your friends and realizing you have enough to give everybody one more. So sometimes we do it that way when we're doing a double digit. I'm going to put 3 here. We know that 3 times 17 is 51. We figured that out. We'll subtract. We have a remainder of 3 tens. We're going to break up those 3 tens to 1. Bring down the 4. And now we have 34 ones. So we know from our division earlier that that would be 2 that we can share with everyone, and 2 times 7, remember, is that 14. Let me close it. Oops, I did not mean to get that off. There we go. So 2 times 7 is 14. 4, carry the 1. 2 times 1 is 2 plus 3, or plus 1 is 3. 34, subtract, and we have a 0 remainder. So double digit gets to be somewhat confusing, but you guys can definitely do it. Let's focus on C here. Let me check for time. I think I have enough time to go over C with you guys. All right, so in C, we have large decimals, where we're going to be moving our decimal place quite a bit. So we have, let's get this in here. 63 10,000ths divided by 7 thousandths. All right, so we start with moving that decimal place in our divisor. So I'm going to move once, twice, 3 times to get that, to make it a whole number. So I am multiplying this number by 10 or by 100. So I'm going to move, or 1,000, excuse me. So I'm going to move my dividend 3 places. 1, 2, 3. They have to be equal. It's always good once you do that to rewrite the problem. So now I have I have 6 and 3/10 divided by 7. They're both going, the quotient is going to be the same, guys, because we've changed both of them the same amount. We've increased it by 1,000, each of them by 1,000. So if I have six ones divided among 7 people, I can't do it. Put a 0. Sometimes kids will put the 0, they'll do 0 times 7 because it's the decimal will be next, and have 0 subtract and 6. Or you can just move on and look at it as 63. We change that 6 into 60 tenths. Bring down the 3 tenths that we have. We have 63 tenths. 7 people. Everybody gets 9. 9 times 7. 63. If you're understanding the movement of the decimal place, doing it when you are dividing by a single digit divisor will go relatively quickly for you. It's when you have a situation like before when you have to change it into a double digit that it might slow you up. But remember, just take your time, use estimation to kind of guide you where you need to go, and you will get there. Thank you so much for watching the video. Tomorrow we'll spend quite a bit of time talking together, and have a good night.